So we are preparing to release Hazel, my game engine, for free very soon. And part of that roadmap is basic multiplayer. One of the two things that I'm currently working on. The other is the new Renderer 2025, which you may have seen me live stream for like the past month. By the way, all live stream VODs are uploaded to my other channel called Cherno Unplugged. I'll leave a link to it in the description below, so you can take a look at all the work that's going into that project entirely on that channel and live on Twitch. Anyway, the other big thing that I'm basically simultaneously kind of working on is basic multiplayer. Now, we started working on this the second half of last year and then kind of took a little bit of a break because I wanted to focus on Renderer 2025. And now we're getting back into it. The way that we left it last time was we had Genesis, this like game that was the first game that I ever made, and then I'm remaking it in 3D now in Hazel, and it's also an MMO, why not? That is now more or less running multiplayer. In fact, more work has actually happened on Genesis 3D behind the scenes because Jim, aka 0x, has been working on animation for networking. But anyway, that's besides the point. The point is we are getting back into multiplayer, we are getting back into Genesis 3D, and I thought that a good way to kind of revive this project would be to share with you how exactly multiplayer works in Hazel and what my plans are for it. It's basically implemented to the degree that I want it to be when we ship this first version of Hazel. I think it's more about refinement now. But here's the thing. As I show you all of this and I walk you through how everything works and the kind of experience that I've designed, I want you to think about it and give me some feedback. I have only ever professionally worked at EA, like on Frostbite, Osiris, like engines there. Obviously at that scale, things are very different, and I haven't really made any kind of multiplayer indie game or anything myself. My goal with Hazel is to try and keep things as simple as possible, which you're probably gonna see in this like multiplayer design and implementation. So for those of you who might have some experience or have tried to make multiplayer games in other engines such as Unity, Godot, Unreal, maybe you'll have some opinions or some weird things that I'm doing here that are gonna make it more difficult for you to potentially use Hazel in the future to make some sort of networked or multiplayer game. So without further ado, let's take a look at Hazel and how this whole multiplayer thing works. I think the first thing I'll show you is this is Genesis inside Hazelnut, Hazel's editor. And then I've also got in VS Code here, I've connected to an actual server. This is hosting a server. And I have this run server command, which is going to run the Hazel headless server. So this is also Hazel compiled on Linux and then uploaded like to this hosting a server. If I go ahead and run the server, you can see it's going to start this scene called main, which is this scene inside Hazel that we are currently looking at. And then if I flip back into Hazel with that now running, I can hit play and you can see it's going to actually connect to the server. The reason I know it's connected is because first of all, the time over here is counting down and the server is the authority for that time. We also have this object here, which is like a little test physics object that is entirely contained within the server. So the reason we're seeing this now is because the client is receiving data from the server and telling it to actually like render this cube at a position, but the actual physics simulation is happening. Well, we can't replay it because it's already been, the physics simulation has already happened. But if I disconnect and reconnect, you can see how like another female spawns over here, and their positions are also entirely dictated by the server. But my point with the cube was just that when the server starts, there's like a physics simulation that plays, it drops out of the sky, lands on this plane, and that is entirely simulated on the server just as a little test. But anyway, these females moving around here, these female entities, which are the pink girls here, they are entirely controlled by the server. And that logic is actually written in C#, much like you would just write client-side code for a game in Hazel. So that's really nice. It's not like custom or anything. It's actually all within this project. Now you can see here they're not actually animating, and that's because we don't have Jim's networked animation code within this branch over here, but that is in fact working. Maybe I'll show some video on the screen right about now. Anyway, the other thing I can do with this still running is I can start an instance of the runtime just to get another instance of Hazel up and running. So I believe we have a build of Genesis for the runtime. So if I just try and, it's not even compiled, if I just try and run the runtime while the editor is also running, then we should be able to connect. Oh yeah, we don't have textures here for some reason because they're disabled. But if we have a look at this, we should actually be able to find each other. So where's the other player? So you can see there's only one other like green player. So if we run to him over here, as I run to him, we should be able to see it inside the Hazel client. And you can see I'm kind of walking around. And if I switch to this one and walk around, we're going to see it move inside the editor. So there you go. That's networking working. And at the moment, you can have like as many of these clients as you want. And obviously like the time is all synchronized. I don't think I'm laying it out properly here. That's why it's being cut off. And also I think when the seconds get down to 0, like 1 minute and 6 seconds, it's not displayed correctly. Anyway, none of that matters. This is in development. Anyway, the point is we are seeing obviously real-time multiplayer happening over here. So now let's discuss how it's actually implemented, both client side and server side, and also my idea for what it would look like to actually make a multiplayer game such as this one in Hazel. So obviously you can't really have multiplayer without a server. And over here we are running on a Hostinger VPS. Now Hostinger have actually been nice enough to sponsor this video as well as all of like these multiplayer networking projects that we've been working on for Hazel. And my experience with using Hostinger servers for both my websites as well as all of this multiplayer networking stuff has just been amazing. They've been great. Whether you just need a simple website or a powerful VPS, Hostinger have got you covered with some of the best value I've ever seen. I've been personally using their VPSs for years for everything from simple websites to high performance web apps and game servers, and they've never let me down. For Hazel's multiplayer, we're using their KVM servers. Across all of their plans, hosting a VPS has used powerful hardware such as NVMe SSD storage and AMD EPYC processors. This gives you super fast and responsive website or app performance. Of course, you also get full root access so you can do whatever you need on your server. They've got some great security features such as DDoS protection and user-friendly firewall configurations, as well as free automatic backups and real-time snapshots. Now, I recommend that you start off with this KVM2 plan here. It's a great little server and it's really great value. However, if you do find that you need more resources, hosting a scalability means that you can easily switch that over to a more powerful plan. Once you've selected a server plan, make sure that you use coupon code Cherno at checkout for an additional 10% discount. Server setup is super simple. You just pick a location and they've even got this like real-time latency so that you can pick the best server for you or for your users. They have a huge amount of operating systems to choose from. This one here that we're using for Hazel is Ubuntu 24, just like our actual Linux computer that's in the office. And then finally, you can set a root password, which you'll need for SSH access. Once that server sets up, which doesn't take very long at all, you can just SSH in and do whatever you need to do. They also have a really great dashboard, which has everything you would expect, as well as some great documentation to help you out. So for all of your website and server needs, head to hosting.com/Cherno, link will be in the description below, and use coupon code Cherno to get an additional 10% off for yearly plans. Huge thank you as always to Hostinger for providing us with some excellent servers and for sponsoring this video. Okay, so taking a look at all of the infrastructure, I guess, that we have for networking inside Hazel, it's basically all contained within this module called Hazel Net. There is some code outside of that, such as like the C# script glue so that we can call some of these functions and use this functionality from C# and it kind of links back into C++. But the actual bulk of everything is inside Hazel Net. And you can see here, there's like 6 files here. It's very, very minimal. It's very small. It's very simple. That's the keyword of this whole project. So we have a client, we have a server, and then we just have some utilities, right? To like resolve, I think we've got like one utility basically. Well, actually this will check if it's a valid IP address and this will resolve a domain name. So that aside, we have this client and server architecture. Now the core of all of this networking functionality starts with this library called Game Networking Sockets by Valve. And so because it's by Valve, you could expect that it's quite well suited to video games. I'll leave a link to this in the description below. It's open source on GitHub, and it also doesn't actually need Steam. So Valve, of course, makes Steam. So you might think that they only want to enforce this for like Steam games, but it works with both Steam and completely outside of Steam. Obviously, we are not using Steam at the moment inside Hazel with the demo that I showed you, and everything is working. So it's a really, really nice library. It's quite popular as well. It kind of combines the best of TCP and UDP because obviously you want this to be performant and work well for game engines and games. Anyway, I'm not going to talk too much about this. I actually kind of covered this a little bit as part of Walnut networking because funnily enough, Walnut networking is basically what you see here inside Hazel. I basically stole Hazel's networking implementation, which uses Valve's Game Networking Sockets, from Walnut, my own library. So Walnut networking is open source. You can see over here, this repository is public. If you go into source Walnut networking, you'll see the same 6 files. Now they've been adapted to Hazel a little bit differently. You can see this namespace, for example, is Hazelnet, and over here it would be Walnut. And I probably have maybe fixed some bugs or added some features, but if you want to take a look at Hazel's kind of networking API, then it is actually open source as part of Walnut. I'll leave that repository in the description below as well. Anyway, all of that aside, let me take you through the API. So I guess we'll start with the server. So the idea is you need something to run a server. Typically, you would make an actual application that is the server. So if we take a look at Hazel Net, this is the net branch of the Hazel repository. I should probably also mention that for those of you who do have access to Hazel via patreon.com/thecherno for $10 a month, thank you for helping to support the project. Over here on the Hazel repository, which you get access to instantly when you support the project, you'll see there is a net branch. And so this net branch, that's what I'm showing over here. So the other branches are quite different because they have no networking functionality. Obviously, this will be eventually merged into like the main branch. But over here inside the net branch, we actually have a few different solutions. We've got Hazel, Hazel Client, Hazel Headless, and Hazel Server. Hazel Headless you don't really need to worry about, and Hazel just combines everything. So Hazel Client and Hazel Server are the two solutions that I generally use. I've been inside the client one, but if we open up the server one, this is probably a little bit better to look at since we're discussing the server. You'll see this project over here under the net folder called Hazel Server, which we didn't see in that other solution. And that has some other stuff here, but the actual core networking API is still inside this Hazelnet module. So this is its own project. I'm going to try and run it now. I don't think I really ran it this year. It still works though, which is great. And so you can see this is the GUI version of the server. So we have the headless version, which is running on Linux over here. And obviously this is also compiled on Linux. This is compiled on Windows, obviously. And you can run this as a GUI or as a headless server as well. So we can run this within like terminal command prompt as a console application. But this is the GUI version, which might be nice if you want to like see some more information visually, like the clients that are connected. And you can also send messages. I mean, you can do that through the command line obviously as well. But anyway, I made two versions. GUI version. The GUI version I think also does work on Linux because when I was working on Hazel server on Linux, because I needed to get it compiling on Linux to actually deploy it onto a proper VPS like this, I think I started with probably the GUI one, which works because Hazel works on Linux, and then I did the headless build. Anyway, most of the code inside Hazel server is for actually running Hazel itself. So it's not really server specific per se, but we still need to do things like open the project, do basically all of the game engine things that you would do, just not the rendering. And the reason why is because we still want the entire game engine to like run in the server, because in most multiplayer games, you need the server to be the authority for everything that happens, like in the scene, in the gameplay that is happening, because you obviously can't trust the clients because any client could just modify itself and then do whatever it wants to. So for example, something seemingly as simple as just those females at the start moving randomly, the server needs to be the one to spawn them, obviously tell all the clients that, hey, there is an entity here at this location, it's moving around like this. But then how do you handle things like collision? Oh, well, you need the physics system, and the server needs to be aware of all of the players, all of the kind of collidable objects, like the terrain, the map, all of that stuff, so that it can actually do that physics simulation and then just tell all the clients that's what's happening. Whenever the player moves and it needs to do a physics simulation, it could just hack itself to go through walls, for example. So the server needs to actually do that simulation as well, and then be like, yeah, that's legit. Like the client has moved into a plausible location, so we can now transmit that to all the other clients. You basically need to run the entire game on the server, just minus the rendering. Typically, you might actually want to keep the rendering if you want to be able to observe things as a server itself, although typically you would just connect as like a client and then be able to inspect everything. So we don't actually do any rendering really as part of the server. At least Hazel doesn't do its normal scene rendering. We do like the IMGUI rendering, the UI rendering you saw for the GUI version of the server. Anyway, that's why this is a little bit complicated, because it's not just as simple as the server receiving data and then reformatting it or whatever and then transmitting it to all the other clients. It actually has to play the game itself. So that's what most of this stuff that you see here is. As far as the actual API goes, it is dead simple, but it's also up to the game to actually control how the server gets started, and if it gets started and how that works, what it does with data that it receives, and also the client side of things. So connecting to a server, sending data to a server, none of that stuff is actually controlled in the C++ code. We just make an API, we make it available, and then it's up to the game to use that API to kind of pull the puppet strings to make multiplayer happen. So we provide quite a primitive set of tools You can see here that in client, for example, the API, it's just got the ability to connect to a server, to disconnect, and then we can set these like data received callbacks so we can respond to ourselves receiving data or connecting to a server, disconnecting from a server, and then we have an API to be able to send data, just as binary data or strings. That's basically it. And then from the server's API, it's basically got the same thing. You create the server object, you start it with a particular port, and then you can set these like data received, client connected, client disconnected, all of these callbacks to respond to certain events as well as send data. And then you've got some other utilities like being able to kick clients. And then these clients will persist inside this connected clients map. And that is because Valve's game networking sockets library actually maintains persistent connections. So really it's doing all of the heavy lifting. We're just providing an API for this inside Hazel, as well as managing like the connections to some degree in a way that games might want to utilize this functionality. And that really was my goal with this, because I, first of all, don't have enough experience in networking and multiplayer to make really strong design decisions to kind of try and shape a path that is somehow going to suit all kinds of games that people might want to make, even games that I wanted to make. Like, I really didn't feel comfortable trying to design this kind of, okay, this is how multiplayer games work in Hazel. You just multiplayer equals true, then suddenly entities will synchronize magically between the client and the server. No, none of that stuff was, first of all, even appealing to me. Like, I don't think I would want to make a multiplayer game that just automatically somehow works behind the scenes and then realize that actually this isn't going to work, or I want to do this extra thing that's not supported. But then the other side of this coin here is that it would be a lot of work to do something like that. So apart from this, like, trying to design this blind, which is not a great idea, it was also, that's going to take a significant amount of resources. And I mean, the first real game that I personally want to make with Hazel, like proper premium game, that's not even multiplayer. That's not, I don't really want to make a multiplayer game. So I don't want to say that multiplayer is like this afterthought inside Hazel. I just wanted Hazel to be able to have networking functionality so that you could theoretically make multiplayer games, but I didn't want to go too hard on locking in some kind of design that all users would then have to adhere to. This does obviously slightly complicate things for games because they then have to implement the actual multiplayer design, you could say, themselves. However, it also gives them the freedom to kind of build their own architecture on top of Hazel that just uses this low-level API, well, relatively low-level API, and that obviously gives the games a lot of flexibility. And that's not to say that Hazel isn't even aware that it has multiplayer. Of course it is. So for example, in this editor scene that we were looking at, if we click on this cube, you can see I've called it server cube, and it's also a different color. Some of these entities are different colors. And if we click on it, you can see that it has a domain, and that domain is set to server. So you can set this domain to client, server, or both. What this means is that these entities, even though I can create them, visually design them, do anything I want. Like, you know, this server cube, for example, is a static mesh. It has a rigid body and it has a box collider. The only reason, by the way, that it's a static mesh is just so that I can see it over here inside the viewport. Because it's set to server, you can see that if I hit play, it's gone. It's not actually in the scene. And that's because this is obviously the client that I'm now playing. However, it does exist on the server. And so does the plane, because there needs to be a plane. That's what the cube collides with. By the way, this secondary cube here is client cube. This is just an entity that takes its positions from the server. You can see it doesn't even have any physics on it because it's just going to be receiving data from this cube, which only exists on the server, and then just setting its position to that so that we can see it inside the client. And then we have this server entity, which also has its domain set to server, and then it has a script, a C# script attached to it, which has a prefab over here, as well as this script class, genesis.servermanager. So if we flip over here to the C# solution, this is all of the scripts, all of the behavior for this entire project. You can see that there are actually two projects here that are game side. There's Genesis 3D and there's Genesis 3D.server. So on this net branch and going forward for Hazel, there's now going to be two different projects. I think if you perhaps choose to make a game that completely doesn't have multiplayer, you probably wouldn't see this project. But since this is like a multiplayer setup game, you would. code. So inside Genesis 3D.server, there's that server manager C# script that we saw over here inside the script component. And this server manager is actually where all of this functionality that is running the server is actually implemented. And you can see that this is just simply an entity inside Hazel. And so it has an onCreate function, and then look at what it does. It uses that server API, which maps to C++, to create a server and start it on this port. And then it connects up all of these callbacks to these functions. It also does some actual Hazel things as well, such as locating entities and some logic like starting a new round by resetting the round timer. And then inside the onUpdate function, I mean, here we're deliberately sleeping for 20 milliseconds just because we don't want it to run too fast. And we don't currently have a way to limit the amount of ticks or updates that a server will do per second. It counts down the round timer, which is the timer that we saw on all of the clients. It processes this event queue of actions. It updates the clients by sending the locations of all the females as well as all of the players. And so if we take a look at this, for example, how do we send the player positions to all of the clients? This is how it works in a very, very primitive way. And I've deliberately left it like this so that you can see just how simple and basic this is. And the idea is you build your own functionality, your own API, your own architecture on top of this to make this obviously higher level. But at its core, we just create this new buffer. That's the size of the buffer. It's calculated like this just because it's counting the sizes of all the variables we're packing into it. The first byte here is kind of like the type of packet it is, and you'll see this when I show you what the client does with the data it receives. And then we just use this buffer.blockCopy function to actually convert all the data from various variable types. So this is like an integer, for example, we're just converting it to bytes, and then we're writing it into this buffer at a particular offset, and that's just the size of the data. Then we just increment the offset by the size of data that we wrote into there, and we go through like all of the players inside here, and then we're just basically sending the player's entity ID so that the client knows which player this data is for, and then just the translation and the rotation as floats. Once we pack all of this stuff into this buffer, into this byte array, we then just call server send buffer to all clients. And we send that byte buffer. It's that simple. Now, on top of this, you could, of course, write your own networking library where you can just basically give it like a bunch of player entities and then it packs it itself. And then the client decodes it in a reliable way as well. You could use some external serialization library. It's really up to you how you want to deal with this and how you want to send data between the client and the server. That's all on you. And so you have the flexibility to really make this fit your needs. This little test, by the way, here directly in the onUpdate function is that cube. So you can see we have the server-side cube. We just grab its translation and rotation, and we just send that buffer to all clients as well. Now, as for receiving the data server-side, we have on data received. And then what that will do is from a particular client ID, it will receive this byte array of data, and then we can decode it. So the way that I'm encoding this data in a very simple way here is the first byte is like the type. So if it's 1, then it's a position update and we respond accordingly. If it's something else, we do other stuff. This mostly applies to the clients because it looks like the server only receives one type of data over here. But you can see it decodes the data from that byte array. And then since this is actually called from the network thread, we queue using a concurrent queue, which is thread safe. We queue this functionality to happen later inside the onUpdate function on the main thread. And that is just to basically try and retrieve the appropriate player and set its data. So for example, update its position and rotation. When players initially connect, that's why you saw this happen over here, client connected. We just happened to spawn a female. That's why every time we rejoined, you saw like another pink female entity appear. And then we add the info about this player to this dictionary, which is the player or the entity ID mapping to the player info, which contains all of this information. Actually, sorry, this is not the entity ID. This is the client ID. And then going through that, we then know to iterate through it and obviously transmit all of that to all of the other entities. Client disconnected obviously works the same way. And then console message event is just a way for us to be able to kind of communicate to the server, to this C# behavior through the console of the server while it's running. So for example, if the message starts with R, we just reset the cube. Actually, that's something that I probably should have showed you. So if we hit play, then we see this cube, which remember I said is controlled by the server. So if I put this over here, let's put this here. What I'll do now is I'll just type in the letter R and hit enter. And you can see that on the client, it's respawned. And that simulation that you're seeing, that physics simulation, is completely done on the server using Jolt, our physics engine. So this is just a way for us to obviously do that. And then you can also see if there are two values inside the message, then it will, I think this will actually spawn a female on the client. So you can see that the ID for the message is actually 0. So if we go over here to the client, Genesis client, and we have a look at this is a good time to transition to the client behavior. You can see that on the client side, again, just an entity inside Hazel, we use this Hazel networking API. So hazel.net.client over here, we create one of these and we try to connect to this server address, which you can see is actually set to uswest.studiocherno.com. port 8192, which is this running, hosting a server. And if we go to the data received event, you can see that if the type is 0, we do in fact spawn a female at the coordinates that come in. So let's try that. If I'm probably close to the origin, so if I just type in 0, 0 and hit enter, then you can see we just spawned a female there. Let's try 2, 2 or something. That's over there, maybe -2, -2. And you can see we are spawning these females. And in fact, they're even making children already. Look at that, happy family. Okay, so on the client side, it's the same thing as you would expect. We're just sending these byte arrays, we're receiving them, we're decoding the messages to see what to do with that. The client side obviously has to also contain these like remote player and female containers because it's entirely in charge of processing that data and spawning its own entities, creating its own entities client side, which represent the remote entities that are actually existing on the server and being simulated and whose behavior is being dictated entirely by the server. And that's it. I don't really have anything else to say. Things like client prediction, lag compensation, none of that exists. It's just raw primitive sending bytes to and from like the client, the server. It's completely up to the game to actually make the multiplayer work well and in a way that suits your particular game. Because for example, if you're just making a turn-based game, you don't really care about like lag compensation or like client-side prediction. Maybe you just want to be able to communicate with a central authority that is your server, and then maybe you just want to have like 2 clients and you want to make a chess game. Like you can do all of that really easily with all of this without having that complexity on top of it that not only might make it harder for you to design the system that you want, but it's also going to make it harder for me and the team because we have to spend time with our very limited resources implementing all of that here, whereas it might not even fit your needs like well. So that is basically where we are at. Where would I go from here to improve this? Because obviously, as you can see, it works pretty well. And to be honest, the API is not actually too bad. What I would do is I probably would provide some kind of C# side serialization, because this is obviously really annoying to deal with. Even if the game would prefer to write this stuff itself, that's great. And it can definitely do that because we're going to leave this kind of low levelness around. However, I would also like games to just, especially if it's like a sandbox or a prototype game or you're doing a game jam, to just be able to be like, hey, look, I got these 3 entities, or here's my list of entities. I just want to send all of that to the clients, for example, because I'm running that on the server. Or I'm the client, I need to send like my position. If we have a look at on update, then I'm sure we'll see send player data. So if we're connected to the server, we're going to send player data, at which point it's going to get our current player entity, the translation, the rotation, and then encode it. All of this stuff should be more or less automatic to do. I don't think that this should be something that you always have to do primitively like this. So I would probably build some kind of higher level way to just send data. But again, it's still going to come down to just sending byte arrays. That I'm obviously not going to change or make automatic like synchronization for, but just this part. And that's really easy. You can just use a third-party serialization library, or we could just provide something really simple within Hazel, which is probably what I would be leaning towards, especially because Hazel, the C++ side of Hazel, actually has a pretty nice serialization API. Like over here, for example, inside the C++ code, mesh runtime serializer. This is responsible for serializing meshes into our runtime format. Serialize to asset pack has a file stream writer that it takes in. This is Hazel's serialization API. And you can see that when it comes to writing data, all it has to do is do like stream.write raw. Here's actually a struct being passed in that's like a POD struct with just obviously data and no like interaction with via pointers or anything in there. And then we just do stream.write raw or stream.write 0 because we have to leave some space to then later come back to. Write array to write this vector, I'm guessing, of nodes. We have all of these tools available to us. We can set the stream position back now that we have the metadata to actually write that in. This is obviously much easier, and this is in C++. So designing something like this potentially inside C# as well shouldn't take more than like a day max of work, and I think it will obviously improve the user experience for doing simple things dramatically. Anyway, that is pretty much my overview over how multiplayer works inside Hazel. When Hazel officially gets released and it's free and it's more or less stable and all the branches are merged together, obviously, I'm going to probably make a tutorial that shows you how to actually make a game from zero that uses this and is multiplayer. I don't want to do that yet because it's not finalized and Hazel's not free yet, so not as many people are going to want to use it. But for those of you who are interested and would like a tutorial, then that will come in the future. So please let me know what you think of this primitive, flexible, we could paint it in two different lights. Either you could say it's like really basic and primitive, or you could say it's really flexible and it's dictated by the actual game project, which is great. I don't know, but I think it's quite nice, and my experience using it obviously for this has been pretty simple and pretty easy. If you are working on more serious projects like, I don't know, a first-person shooter like Counter-Strike, then you'd probably want quite a lot of client-side prediction, lag compensation, obviously stuff to make it more fair. And also what happens if you start dropping some packets, and like there's a lot of edge cases and there's a lot of like refinement, I guess, and polish that would need to be done, especially for a competitive level game. However, I'm not an expert in that, and I feel like games that are multiplayer at their core, and that's such an important core experience to that specific game, might want to design their own system around it, since that's so important to that game. And since Hazel provides so much other stuff like rendering and physics and all that, if you wanted to make a multiplayer game and you wanted more control, then maybe Hazel would be an engine you would pick, because you could spend as much time as you want in both C++ and C# designing the perfect multiplayer system using our tools potentially, and you could really refine it and make it your way. If you would like to support the Hazel project and help us get closer to our free release, then please go to patreon.com/thecherno. You can sign up and get instant access to all of Hazel's source code, including all of the branches like this net branch. Everything I've shown you here, all of this engine side functionality that I've shown you here, you can get access to instantly right now. And a huge thank you as always to all the supporters that make Hazel possible. If you need web hosting or servers, then definitely go to hosting.com/Cherno and use my coupon code Cherno for an extra 10% discount. Link will be in the description below. If you have any more requests for something that maybe I didn't cover today or that you'd like me to take a look at, also leave them in the comment section below. Thank you all for watching. I'll see you next time. Goodbye.